My name is Sally Phelps, and I'm the Director of External Programs and Partnerships at Olin. I am extremely excited to bring you the next segment in our series, Alumni Perspectives in Sustainability. And I'm especially pleased now to introduce our guests. Erica Boeing, class of 10, is founder and CEO of Accelerate Wind, where she's revolutionizing rooftop wind energy in the commercial and industrial spaces by drastically lowering the cost of small wind turbine technology. Erica has worked as a systems engineer, designing and patenting new energy, water, and waste technologies for small base camps, has completed a Fulbright scholarship in the Netherlands, and has worked as research fellow for Project Drawdown, where she performed climate and economic modeling, which contributed to Drawdown, the best-selling environmental book of 2017. And I have to show, I have my copy of Drawdown, which you can't see because of my funky background. There we go. Love this book. All the problems of our planet in one place. Erica is a systems thinker and problem solver, most comfortable developing products that require knowledge from a wide variety of disciplines. Meg Litterbach, class of 17, has been in the wind industry since she left Olin. Meg started her career at GE Renewable Energy, where after completing a rotational development program, she joined the system simulation team and helped design the 3.3 140 onshore wind turbine. Next, Meg moved to Vestas to learn about the offshore side of the industry as a siting engineer for offshore wind farms in the US. In April, she started an exciting opportunity at startup Gulf Wind Technology, a company where she's focusing on developing rotor technology suitable for hurricane-prone regions. Ellie Funkhauser, also class of 17, transitioned from mechanical to test engineer at an airborne wind energy startup in 2021. Ellie enjoys fieldwork and picking the brains of nearby EEs. Outside of work, she enjoys hanging out at coffee shops with friends and being an insufferable bicyclist around Durham, North Carolina. And with that introduction, I will hand it over to our wind team. Thanks for coming.
Thanks, Sally. I guess I can kick us off because I think when most people think wind, they might think of the traditional three-bladed horizontal axis wind turbine. And so that's where I've spent all of my career. But I'm really excited that we're also joined by Ellie and Erica, who have a different perspective on wind and one that might be perhaps more relatable to everyone on the call. So yeah, I guess a little bit about myself beyond what Sally said. So Gulf Wind Technology is where I'm working now, and we are working on developing a rotor that's suitable for hurricane-prone regions. So the Gulf of Mexico is our primary use case, but it could be broadly applicable around the world to Southeast Asia, India, and other locations. And it's the first time I've worked at a company that's a small company that is not a multinational, at least not yet. And it's been a fun experience to learn a little bit more about kind of the small company life and being able to wear different hats and yeah, try my hand at different areas of the wind industry. And so I guess as we go through this presentation, we are hoping to save about 15 plus minutes at the end for questions. But then when you have questions, I can hopefully address anything you have about the traditional kind of utility scale wind that you might see as you go on a road trip across the country. Erica?
Cool. Yeah, I could jump in. So hey guys, I'm Erica Boeing, class of 2010. Done a number of different things since Olin, but the last 6 years or so, I've been working on a startup that I founded called Accelerate Wind, and we're developing affordable wind energy technology for commercial buildings, and you can see a picture of our turbines up on the upper right-hand side. Later on, I'll tell you all about them, so I'll save that for later. But yeah, as we go into Q&A as well, I know a whole lot about the small wind industry, specifically in distributed wind, more on-site generation, and also just like hardware startup life in general. So happy to talk about any of those.
Cool. And I'm Ellie. I'm representing the lower left quadrant of this slide. known as airborne wind energy or energy kites. It's basically a drone that flies around on a tether. And when it gets going fast enough and the wind's blowing hard enough, the propellers turn into little wind turbines and it sends energy back down to the ground. So I can speak to that kind of segment of the experimental wind industry. Yeah, that's me.
Come off mute, Meg. So yeah, maybe just to set a little bit of context about why we might be here tonight, learning about wind and different aspects of wind power. Wind is a great renewable energy generation source. It complements solar really well because solar obviously can only generate electricity when the sun is shining. And peak demand is often either earlier in the day or later in the day, kind of before the sun's at peak power. And wind, though variable, is on average more consistent throughout the day, so it can help to kind of balance out those deficits caused when the sun sets or it hasn't risen yet. And seasonal variation as well. It tends to blow stronger in the winter, might be a little bit weaker in the summer, but still a solid source of energy. On the right, we have a levelized cost of energy or electricity chart from Bloomberg NEF, just showing the kind of relative cost of some different electricity generation technologies. So you can see that kind of as technologies are newer, they might be more expensive, represented maybe by battery storage there. The cost has come down significantly in the past couple of years even, but it's still one of the most expensive on this plot. And then traditional kind of fossil-based generation tend to be cheaper, but now we have started to see within the past few years really that onshore wind at the utility scale in particular is cost competitive, if not outright cheaper than coal and gas powered electricity. So really exciting to see that curve. And as offshore wind also grows to the same scale as onshore wind, we expect that curve to come down too. So not only is it a clean source of energy, it's cost effective for the most part. Obviously, it depends on where you're siting and where that technology is on the curve. So I don't know, Erica or Ellie, if you want to add anything about where your technologies might be.
Yeah, I'd say we're probably kind of somewhere between battery storage and onshore wind. So the whole point of what we've been designing is trying to get to the same cost as rooftop solar. I'll talk more about that later. But we're definitely like still kind of in the pilot phase. So we're starting the curve there for distributed wind. And
Same thing.
distributed wind in general, just most of them are still pretty expensive, and there's a lot of startups that are working on reducing that.
Yeah, same in airborne wind, very experimental phase at this point.
Awesome. And I guess the last thing on that side is just that there's a myth out there that a wind turbine, at least on the utility scale, won't ever repay its carbon footprint. It's not actually a green source of energy, but that's completely false. Most turbines out there will kind of recoup their carbon budget within 6 months of operation. So for the vast majority of their operation, they are operating at effectively zero emissions. And I say effectively because there's some like oil and lubrication that needs to go into the bearings and so forth. But beyond that, it's free energy.
All right. And I'm here to talk about what I think of as like maybe my first order take on working on this kind of technology, where you've got the choice between maybe working at like a big multinational like Meg has done, where you are like making something that is clearly very useful. It's already utility scale, but you're maybe like a smaller cog in a larger machine. There can be an intimidation to working on an established technology like that. Whereas things that are more startup phase tend to be very fun. You can often play a big role in developing the technology, but its usefulness has not yet always been proven. But today, I mean, that's like, you know, the first order take on it. Today, I think we're going to complicate that a little bit. Meg can speak to how much fun it's been for her working on horizontal axis wind turbines, and Erica and I can speak to the things about rooftop wind and airborne wind that are doing very useful work for the renewables energy. And then also there's like, if you're not having fun, you might just have a deadline coming up, and after that passes, you'll feel better. So that's many engineering jobs are fun as long as you don't have an extremely stressful deadline. So kind of wind basics of like, where is it and where is it useful to get it? This wind shear curve is like kind of a classic thing to look at. Wind is affected by friction with the ground, like everything else. So near the ground, there's very, very little wind, especially by obstructions. And then as you get up in altitude, you get much faster, quote unquote, cleaner, like less turbulent wind. So the basic idea with a lot of on and offshore utility scale wind is like get up very high in a very flat place. And same thing with airborne wind energy. It's like, you know, you have this long tether, so you could theoretically access higher altitude, cleaner wind. However, Erica at Acceleration. Oh yeah. Ken, turn off your speakers. Thank you. Your mic. Erica has found a way to harvest wind in like cities and urban settings, and she'll talk about that. Also, Ken, did you have a question?
No, it's just that Zoom always starts with your mic on instead of it like turned off on like Teams.
It is problematic.
Awesome. Yeah. So I guess one of the key principles of at least traditional kind of utility scale 3-bladed horizontal axis wind is the Betz law, which basically says that the maximum energy you can extract from the wind is 59.3%. So you'll never be able to get 100% efficiency. You'll never be able to even get that 59.3% efficiency from wind energy. And it won't ever be that value because there's always going to be friction and other things that pull you away from that idealized 59.3%. So yeah, the wind coming in, the wind turbine will extract some of the energy from the wind and then it'll slow down the flow. And so that is also a concept we call waking. And I love the picture in the bottom right. That's a picture, it's an iconic one in the industry of Hornsrev wind farm. I think it's in Denmark. It was a foggy or cloudy day and the wind was just right. And you can see how those front row turbines are really just dispersing the wind. And so therefore all the turbines that are downwind of those will have an even lower efficiency because their wind speed is already slowed down. And it's much more turbulent air as well. So they'll face higher loading and some other considerations. But yeah, this is just kind of the governing principle of at least horizontal axis wind turbine energy extraction.
Okay, so yeah, as Ellie just told us, oftentimes the fastest wind is the further up you can get in the atmosphere, the better. At Accelerate Wind, we've taken a slightly different approach, and we've developed a turbine that can take advantage of the fact that buildings create a natural blockage effect, and the wind has to speed up in order to get over the building. So you can see that happening. Here's kind of a classic CFD image of that happening here, where wind that you would normally need to get way higher into the atmosphere to get wind that's that fast. And so it all started actually with an idea that I had while I was in the Netherlands, trying to say, hey, can we take advantage of this faster wind to produce meaningful power, because it looked like there was really a lot of promising wind there. And so we've been pursuing that for the last 6 years. And yeah, if you go to the next slide, I can tell you a little bit more how we've done it. So as you saw before, wind speeds up at the edge of the roof, but what we learned pretty quickly as we got into it was that you tend to still get a ton of flow separation at the edge of the roof. So it hits the roof, separates pretty quickly, and you would still really need a tall tower to capture it, which would be ugly and expensive and just really not make a lot of sense. And so what we've done over the past several years is we've found that there's a range of airfoil shapes that we can put on the edge of the roof, just like over to the right here. And we can actually draw that faster wind down to the edge of the roof so that we can capture power right at the edge where the turbine won't interfere with solar, which will already be on the roof. and where it's affordable and you don't need a tall tower to capture it. And so that's what we spent most of our time doing. Our core IP is all in how do we draw that faster wind down to the edge of the roof, and we've patented the range of shapes that will let us do that. And actually, we've worked with a lot of Oliners over time as we've been developing this. We've run thousands of computational fluid dynamics models, and a lot of Oliners have helped contribute to that, among many other things over time. I know there's a few in the Zoom right now who are working with us. But yeah, so that's kind of a big piece of the key to our technology. And by drawing the wind down to the edge, we can capture about 3 times more power than competitive solutions and really make it affordable to be able to capture wind at the rooftop level. There's more complexity to it than that, but that's kind of and a lot of optimization work that we've done around supply chain and how we've designed the turbine. But that's a big piece of it. And it looks pretty cool if you go to the next slide. And I guess you can see it behind me as well. Oh, right. I forgot that I had this on here. This is pretty cool. So the effect of drawing the wind down to the edge of the roof. That's something we were finally able to see live just this past year. We have a wind turbine test site in about an hour south of Salt Lake City, Utah. And we've built up a mock building there. And it's in this canyon where the wind almost always comes from the same direction. And so you get really predictable high-speed wind. And we were able to run a test where we hung snow machines at night off of a forklift and use a spotlight to illuminate the view over the building, and then use image processing and a GoPro to track each particle as it went over the edge so that we could compare it to our models and really show that we were drawing as much wind down to the edge of the roof as we thought we would be. And it worked really well. It actually, in real life, it performed better than our models, which is crazy. But you can see a little video of that happening right here, where you can watch the particles just kind of glide over the building if it loads. There we go. Yeah, so it's almost textbook the way that you can see it just kind of like hovering over the top. I got very excited because I've been working on this for like 5 years and never thought I would actually see the effect live. So it was really cool to see this actually happen. Yeah. Next slide. And our turbines look pretty cool too. So this is an image of what they will look like installed. This is actually what our a rendering on our office building that we're at. But designed just like solar, so that they can be installed in modules, and you can install any number of turbines depending on how long the building is and how much power you want to produce, and also designed to go alongside solar. And a really important cost reduction piece of our design is making sure that solar installers can install them using people that they would already have on site at a solar installation. And that's actually probably just as big as our edge of the roof technology in terms of being able to get the costs down of the system. So we spent a lot of time working with them.
Awesome. Yeah, so I think if we can transition, we'll go back to kind of the traditional view of wind a little bit. I've had the pleasure to work with 3 different companies across my career so far, and learn a little bit more about the industry each time. So when I started out, I was at GE Renewable Energy, now called GE Vernova, where I helped to design their new onshore wind turbine shown there in those pictures. It's called Sierra. And that was really an interesting experience, learning how to conduct load simulations of the system, all of the different kind of factors that go into designing a wind turbine, working with the systems engineers, the component engineers, and really everyone on the team to pull together and make this thing happen. And now I believe it's one of the better selling onshore wind turbine units in the US. So that's a really cool accomplishment. And then after that, I went and worked with Vestas, who is, I think, the largest global commercial wind turbine supplier, where I focus more on the offshore wind industry. And so this map that you can see in the middle of the slide is a map of wind energy areas and lease areas that BOEM, the Bureau of Ocean Energy Management, is managing. And so the ones that are named, you can see kind of in the top left for the most, or excuse me, the top right for the most part, 1 through, where does it end? 1 through 9 or so are all projects, leases that have been sold. They're in some stage of development. Vineyard Wind, number 4, is the first one, and it's actually being installed now. So if you fly into or out of Boston going south, and you have a window seat on the right side of the plane, you might start to see some turbines in the water if you look really close. So pay attention to that next time you're in the area, or maybe New York going over to Europe or something. But yeah, hopefully the goal is, I think the Biden administration has a goal of 30 gigawatts of offshore wind installed and operating by 2030. There's been some setbacks to project development in recent years between COVID, the war in Ukraine, inflation, and so on, that are maybe going to challenge that timeline a bit, but it's still, I think, a worthy and ambitious goal. And then, as you can see, they do continue all the way down the East Coast. There was the first lease auction in the Gulf of Mexico recently, where one lease area was awarded, and there's a few leases that have been awarded off the coast of California as well. So it'll be a while before there's turbines anywhere but the East Coast. It'll be probably at least 5-8 years or so. But it was exciting to see the just incredible scale of those turbines in the offshore side of the market. If you saw on that first slide when we were each kind of giving our overview, the top left picture was the Vestas V236 15 megawatt nacelle, prototype nacelle, rolling down a road in Denmark. And it's honking, it's huge. The blades are each 115 meters long. I honestly, the whole industry uses metric, so I don't even know what that is in feet, but it's gigantic. Yeah, it's exciting. And then at Gulfwind, yeah, we're focused on rotors. We don't design the drivetrain, but we are trying to help innovate in the onshore wind, or excuse me, the wind industry in the area of blades. So one of the projects I'm working on is helping to design a rotor for the Gulf of Mexico and other hurricane-prone regions. And that's a really difficult design statement because the Gulf of Mexico in particular has a relatively low wind speed for offshore wind. It's around 7 meters per second, maybe 7 to 8. Versus, for instance, off the coast of Massachusetts, it's closer to 10. And so because it's a slower wind speed, generally that means you want a much larger rotor. But the larger your rotor is, the more loads get transmitted into the rest of the system, not to mention the blades themselves. And those loads are generally governed by extreme events. And a hurricane is about the most extreme event you can get. So when you have a really high occurrence of extreme events, you generally want a smaller rotor. So those competing design statements are really where we're trying to innovate and find a solution that can work across both of them. And I do just want to point out that broken blade is not a Gulfwind technology blade. We've helped to get to the root cause of those types of failures, and help to offer repair solutions for onshore customers currently. And I guess once there's turbines up and spinning in the offshore market, we'll help address their problems as well. But yeah, that's a little bit about kind of my experience with traditional utility scale wind, and where we're going. So I will plug Gulfwind is hiring, and we'd love to see some more Oliners on board. I think with that, next slide, please. So yeah, wind, I think any type of wind, but especially, utility scale wind is the most widely kind of deployed currently. So we know maybe the most about its concerns and impacts. It doesn't, there's no such thing as a free lunch. There are unfortunately downsides to every source of electricity generation. For instance, with offshore wind turbines and onshore wind turbines, it depends on where they're sited, but there's a lot of coverage in the news currently about how wind is killing whales. Ellie actually spoke with a friend of hers who's an ecologist who said, well, it's not wind that's killing whales, it's some of the siting activity, and it's not just for wind energy, it's also for oil and gas. So it's trying to understand what kind of the seafloor looks like in those offshore areas. It's somewhat disruptive, and it's apparently disruptive in a way that might be harming whales. Although I think the expert agencies such as NOAA would all weigh in and say that those relatively localized risks from those siting activities, especially for offshore wind, are greatly outweighed by the benefit of helping to avoid the worst effects of climate change. So wind really is kind of our best bet there in terms of an immediate, rapid solution to help us decarbonize our electricity grid. Some other concerns are around bats. It's not necessarily from striking the blade, but it's the pressure change when in the rotor plane. And so if they come too close to that, they get basically pressure trauma, and it can lead to fatalities, unfortunately. But there are mitigations in place, such as either turning off the turbines during areas of or times of high bat activity, or other mitigations that are under development to help maybe keep the turbines spinning and producing energy. But yeah, so everything has its costs, and I will say the wind industry is definitely working really hard to help minimize its negative impacts, both on a carbon footprint basis in terms of the actual kind of sunk carbon of the machines themselves, and also their ecological impact. It's definitely top of mind for pretty much everyone in the industry, and it's something that everyone's working to help address. So with that, I think next slide. Thank you.
Thanks, Meg. I'll speak to energy kites a little bit. This picture is not of a wind lift craft, but a company called Makani that made a ton of progress. They got like big Google funding, and they were around for 10 or 15 years. And then when they finally ran out of money, they like released all of their information and findings publicly, which was very cool. But yes, energy kites, the kind of stated use case is that they are quite lightweight and portable. So the idea is that you may have situations where you would like to have access to a green source of energy, but maybe not for long enough, or not with enough time to wait to put up like a full wind turbine. Whereas like an energy kite you can deploy in under a day, and it just kind of zooms up there and starts sending kilowatts down the tether. So while I don't think that there are energy kite companies that have fully proven out utility scale power generation yet, but many of us have proven out like lower scale power generation, and basically like the autopilot development is the big hurdle. So working on it at a smaller scale lays the groundwork for eventually creating larger versions of this technology. You know, like you get the advantages of this kind of easy setup, quick prototyping, lightweight, maybe long tethers, allowing you to access higher altitude winds. But like in return, you have to deal with everything involved in putting it on a plane. You know, like traditional horizontal axis wind turbines, like you get the normal force for free. But a plane, you don't, and they're, you know, a little finicky. So I would say those of us working in energy kites, there's been it's driven a lot of smart flight controller progress, which is very exciting. It's very fun to work on. It's like a huge optimization problem, because everything that it could improve performance costs you weight, and weight is like the ultimate no-no. So it's always like kind of a fun balancing act to work on from an engineering standpoint. And also, like theoretically, if they are deployable offshore, you could deploy in deeper waters, because you don't need a full foundation. You just need like a buoy and a bunch of anchors. How you are going to get that energy back to shore is none of my business, so please don't ask me about it. And off to Erica.
Yeah, so diving in a little bit more to rooftop wind, I took the fun and usefulness graph literally, and wanted to talk about the fun and the usefulness of rooftop wind. So as Ellie was just saying, rooftop wind energy generation too is just a huge optimization problem. I think all wind energy generation is a huge optimization problem, but one of the things that I really like about working in this industry is that you can really hold the whole product in your head. It's a super multidisciplinary product, and it's important to understand the customers, the permitting, but also the mechanical and electrical engineering and the aerodynamics, and really the interplay for all of those. And so, I know a lot of Oliners are really good systems thinkers, and so that's something that's really fun about being in this industry. And I think there's a lot of low-hanging fruit as well in terms of systems optimization, just because rooftop and small scale distributed wind has traditionally been run by a lot of smaller companies that just haven't had the time or energy to do this kind of optimization. And so there's a lot that could be done to improve these technologies, and that's a big piece of what we've focused on. And then to talk about usefulness of rooftop wind, there's pros and cons. It's but a lot of pros these days. So one of the biggest things that has changed since we started the company 6 years ago is in the last 1 to 2 years, I've seen a huge shift in commercial buildings looking for technologies for on-site generation. I think this is driven by a whole bunch of things. It's partially the IRA, and it's partially the fact that a lot of big corporations are feeling pressure from even employees to sign up for decarbonization commitments. And a lot of CEOs of these companies have signed up for commitments that they just have no idea how to meet. And there's a big push for on-site generation as a more pure kind of impact, rather than just paying for retiring some renewable energy credits elsewhere. You could actually count it when it's on site. And so people who would kind of talk to us 4 or 5 years ago when I started, but be pretty conservative, are now very excited and looking for solutions for on-site generation. And so it feels like it's really at a good time, that it's filling a good need. And then this is probably true for most of wind, but because it's local, there's resilience and intermittency challenges that it can solve. So in terms of resilience, we're talking a lot to the Air Force right now, because they have huge resilience goals and huge decarbonization goals, but they can't use tall wind turbines because they'll often interfere with flight paths. And so they're really excited about us having something that's closer to the ground that can help them develop a resilient solution. I also think we've gotten a lot of resonance with a lot of people in more rural areas just by the taking control of your own energy, and because it's something that would be owned by the people who own the building. There's a control and autonomy and freedom element to it as well. And also rooftop solar is doing pretty well, and by focusing on developing the cost so that they are cost competitive with solar, that lets us provide a complementary solution and help buildings get closer to net zero as a whole. And then also a lot of people are excited, and one of the reasons that I got into this to begin with was just an awareness that the more people are seeing renewable energy around them on a day-to-day basis, the more normalized it'll become. And so having wind turbines on buildings that are visible for people to see is a different kind of impact in that way. On the con side, it's not a silver bullet. None of these things are, but we definitely can't produce all of the energy that would be needed. And even still, on some buildings, it may only produce 10% of the overall energy demand. It super depends on what the building is designed for. But as a company, I see us moving more towards how do we provide holistic solutions for commercial buildings and decarbonization? In the end, not wind is the be all end all only answer. And small scale wind will probably never have quite the economies of scale or costs as utility scale wind. Rooftop solar also is quite a bit more expensive than utility scale solar. So there's a cost trade-off there. And then as a new technology, there's a really long development timeline. Wind prediction is one of the big things that we're working on solving right now, because it's a lot more complicated than solar prediction on buildings, because the obstructions will block it. And so there's a lot of things to work through in order to really scale up this technology, and that takes time. So.
All right. I wanted to provide a maybe cautionary note to our young engineers. I mean, me included. I think we all, seek out work and sustainability because it feels good to like use your skill set to do something positive for the world. If you're like me and you have a mild slow burn climate panic at all times, your job could possibly help with that. But I would say a lot of the climate problems are not engineering problems. They're political and social ones. Like ultimately, energy use reduction is going to be a much bigger piece of the pie, and than a lot of companies will lead you to believe. It's not just like creation of new technologies that we have to do, but reduction of energy use. So your job probably can't provide all that for you. And also, like, companies can greenwash, and they will when they make job postings. They know that you are a good-hearted person and that you want to do work that matters. So every job posting you'll pretty much ever apply to will be like, this technology is somehow good for the environment. And just take that with a grain of salt. Like, do a little bit of like first principles evaluation. Does it actually seem like a good idea that will help decarbonize the earth in a meaningful way? Or is it just like a very small chunk of the pie that they're getting a lot of funding for? The funding, I mean, like the profit motive is a thing. Like, no matter what a company's stated goals are when they talk to you about their work, their real goals are probably much more related to their source of funding and profit. So just be aware as you launch your sustainability career that there are very meaningful things to work on, and there are things that will be pitched to you as very meaningful. But ultimately, I would say like just try and get your foot in the door, because a lot of this will become clearer the longer you're in the industry. Like you'll be more able to pick out meaningful work.
And if I could just add, Allie, on that last note, Ben Linder has offered to any student, any alum, to help you assess a technology or a company, a startup maybe that you're going to considering working for. So I think that's really good advice, Allie, and feel free to find Ben, if you can find Ben, who is always happy to help with that.
That is cool. Thank you, Ben Linder. Thank you, Sally. All right, back to Meg for some optimism. In my defense, I'm a test engineer. My job is literally to be pessimistic.
No, and it's a good thing to remember, and definitely true. I mean, every company has its demons in the closet, right? Like nothing's inherently good. At least I haven't found it yet. But so I guess just to kind of wrap up, I think all three of us can agree that wind, whatever form of wind energy, is a fun engineering challenge. There's a lot of trades to balance, optimizations to solve for, new problems to go and tackle. There's just kind of an endless engineering challenge that can provide careers worth of learning and enjoyment and challenge and fun. And I think also kind of what we want to point out, and we're using the kind of traditional wind view on the right, but it applies, I think, to all three of the technologies we discussed today, is that the wind industry is more than one type of major. It really takes everything. For kind of traditional utility scale wind, we need geologists, seismologists, hydrologists, depending on whether it's onshore or offshore turbines, to assess how the foundation will sit in the ground. Structural engineers design, the towers, the internal structures, foundations. Mechanical and electrical engineers are all over the hub and drivetrain, really the whole system. Aerodynamicists and material science engineers do a lot of work on the airfoils and blade structural design and blade design. But beyond the turbine itself, we need people in the industry who are ecologists, who think about the impact of these solutions on the environment around them, which also could include environmental scientists and also maybe sociologists to help sell the idea of wind turbines to the local population who might be, putting up a fuss about it. Atmospheric scientists, meteorology, and climatology help us understand our inflow, our energy source, the wind, and how that might change over time, especially with climate change. And then on the more business side, finance, business, computer science, sourcing and manufacturing experts, process engineers, the list just kind of goes on and on. So regardless of what your background is or your area of expertise, odds are there's a wind company who will gladly hire you. And I think for the most part, the wind industry it's had a couple rough years, especially, but I think for the most part, the whole world has recently. But I think a lot of them are very optimistic about the future, and a lot of them are hiring. So with that, I think we just wanted to kind of have this slide up while we maybe move to our question section of the talk. So there's a couple links or resources on the right. NREL is a really great one, the National Renewable Energy Laboratory. It covers all of the technologies we've talked about. You might have to do a little bit of smart searching, but they have some really good stuff there. The American Clean Power Association is more focused on utility scale wind and solar and battery storage, but a great resource as well. And then there's this one link on airborne wind energy in particular from NREL. So with that, I think we wanted to open it up to the group.
Thank you, Meg, Erica, and Ellie. I would love for people to either raise your hand or just put your question in the chat. Either way, we would love to hear from you.
Annie, fire away.
Hi, you all. Thank you so much for this presentation. And I just want to ask about something that I think all three of you touched on at some point. Ellie, you mentioned that some of your experiences in the sector with that some of the challenges were more kind of social. And I wonder if any of these companies that you guys work with or have seen actually try to engage with more on that policy or community engagement educational side. Kind of talking more about maybe, Erica, what you were saying, some of these issues are more about just normalization, like normalizing how people see these technologies. So any of those engagements.
I can jump in. So I've always worked for kind of the OEMs, the companies that design the turbines themselves. The developers of the projects are typically the ones who are experiencing maybe the local pushback and some of the maybe misinformation campaigns brought to light. So I haven't necessarily had direct involvement with that, but I will say, I think the developers will often come to the OEMs or maybe other groups like government groups or state, NGOs of various sorts will maybe come to the OEMs for kind of the facts about their products. So in that way, there's been some indirect engagement and providing more about, here's actually the nuts and bolts of what our product is and does and can do. And yes, these are some drawbacks, but those are being overblown in that argument. So for instance, like with the, wind turbines are carbon negative until, or excuse me, carbon positive. They don't recoup their footprint until like year 18. That's just a complete falsity. So there's been some kind of misinformation campaign battling, but.
Yeah, we've touched on some of these issues too. A lot of our time has been spent in engineering world, and so a lot of it's been done through design. It's kind of similar, like typical UOCD, like stakeholder engagement type design practices, and a lot of work done on like getting feedback on the aesthetics, particularly of our turbine and how different stakeholders will react to that. So we've been very intentional about that piece. But then we've also seen elements of that in other parts of the industry. So the Distributed Wind Energy Association, every year we attend a lobby day in order to to educate like Congress about different parts of the wind turbine, and in particular a lot of issues around some of the soft costs like permitting of turbines, and what needs to change to make that easier. Those for wind and solar, that tends to be a big thing. And so I've engaged with that a little bit. And then National Renewable Energy Lab as well. They've done a lot of very intentional work, and we've worked with them a lot to design our turbine for certification. But on the small wind side, there's some of the social issues actually are a lot of people early on put out turbines that just weren't ready, and caused a lot of harm to the industry in terms of reputation and safety concerns. And NREL's done a lot of really good work in there to bring the small wind industry along, and develop a certification standard that can prevent a lot of that from happening, and educating the public on like what to look out for. And so that's been really useful as a guide for us as we've been developing our technology.
Yeah, Windlift works a lot. Oh yeah, honestly, I don't have a super substantive answer for this, so Al, probably go ahead.
I saved you, huh? Okay, so first of all, thank you. This was great. I find it really interesting that each of you work in kind of a different aspect of the field. Some big company experience, smaller company, your own startup, etc. Just that perspective is really interesting. I do want to ask product and technology questions because that's where I came from in my whole career, but I'm going to ask that later if others don't have questions. How do you find the industry that you're working in as young women in that field? The industry I came from, the computer software industry, technical software in particular, is heavily dominated by white males, as you might know. But when we go into healthcare and technology, for example, we find a much more diverse workforce. I'm not really familiar with the workforce in your industries. Who are you surrounded by, and what kind of work environment do you find in the companies that you've worked in?
I'll note before Meg and Erica answer that this is further kind of made interesting by the fact that all three of us are in the South, which, speaking as a native Southerner, has worse gender dynamics than the Northeast or California. But yeah, Meg or Erica, feel free to go ahead. I mean, I work with men, but they're lovely. That's my take. They've been great.
Yeah, it's interesting. The distributed wind industry is actually, aside from like honestly our company, is shockingly male. Like I go to a lot of the conferences, and I'm surprised like that, like I'm really in the minority as a woman. But there's a few, and that's changing. And I think the clean tech industry as a whole attracts a lot of women, and we've without trying, honestly. I mean, I care about it, but it's just like who has made sense for us to hire. We've almost always been over 50% female in our company, which is really nice and a refreshing dynamic.
Yeah, I think it depends both what company you work for, I think, and where in that company you sit. So for instance, within the engineering group, I would say it was male dominated, but not like overwhelming majority. I think I think like Erica was mentioning, clean tech and renewable energy in particular attracts a lot of women. I don't know any statistics on that, if it's like statistically significant more women than men to the industry or not, but so it's probably better than like a similar type of team environment at an oil and gas type company, if I had to guess. But I think it's mostly tied to, there's still across the country more men graduating with engineering degrees and using those engineering degrees as engineering degrees than women. So I think it's still kind of the whole systemic change catching up and taking shape. But yeah, I mean, I guess just anecdotally, I would say that it's not as overwhelmingly male predominant as other industries might be. But again, it varies kind of broadly from company to company and team to team.
My impression is women are drawn more by the cause into certain industries as opposed to purely the technology. And I would hope that climate change broadly and all the technologies that will contribute to helping us out of this hole we've dug as a culture would attract, more women. So that's why I asked the question. Yeah, thanks for that. I guess I have the floor, so I'll just say quickly, Erica, very cool product concept you're working on. How far is it from being in the marketplace? And does it have moving parts? Are there blades sitting up on the corner of the building there? You said that was a rendering. You're accelerating wind over a place where people are potentially working. What about noise? Could you comment on those things?
Yeah. So how close are we to commercialization? We right now are doing kind of our what I'm calling like the final shakedown test at that test site in Utah that I mentioned. And so that's our like thoroughly test and measure all the loads, make sure that it's way over designed factor of safety wise, and then get ready for paid pilots. And so we're expecting a paid pilot within the next year and doing that for a couple of years so that we can work out all the little bugs and then certify and scale up the turbine. And in terms of noise, our last prototype that we built was only like 40 decibels. So kind of quiet library conversation. And our turbine that we're designing now is different. And so we'll be testing that now in the shakedown test and doing really thorough acoustic measurements. But from an engineering standpoint, it should be possible to get to a similar level once we go through all the refinement, because it's a pretty stable configuration. So we're not too worried about noise. It's more of a detailed design challenge. So did that answer all the questions, or was there something else?
Are there blades moving on the top of the building there?
Yeah, I don't know if you can see behind me a little bit, but each of the turbines, it's if you Google well, actually, they're vertical, what are typically called vertical axis turbines, of the lift driven version. And so each of these, there's 3 blades on each turbine, and they rotate around like kind of a paddle wheel isn't the right term because it's a lift driven thing. But yes, they rotate, and that's why factor of safety is super critical, and we're like way over designing them for all, especially our early installations.
Thank you. Good luck.
Thanks.
I just want to call attention to a link in the chat if you wanted to register for the 4th in the series. It's coming up on November 7th. We'd love to have you all there. If there are no other questions, I would just love to have Claire Rogers say a little bit to this group. I think we have some alumni who don't know about the work you're doing, Claire, with the solar project over our parking lot. And even I think the rest of us might be a little fuzzy on the whole thing. So if I could put you on the spot a little bit and ask you to talk about that, it would be great.
Sure. Thanks, Ellie. Hi, everyone. Good to see some of you that I haven't seen in a long time. Back in 2019, I had 2 Olin interns who were looking at what types of renewable energy we could start with at Olin, and they proposed solar. So since 2019, we've been working on getting solar at Olin, and in September, broke ground on starting a carport solar project in Lot A. So we're excited by that. It should be complete end of December. And fits into our new climate action plan that we're working on. So solar will only be one of the many things as we rethink about the central plant and using natural gas and everything. But really excited to kind of have this first step in that direction. And one of the key components has been student involvement with the company. So that students can see both the technical piece, but also the construction, project management, design drawings, permitting with the town, zoning laws, and kind of everything from nuts to bolts of what goes into making something like this happen and feasible.
And what will that do for us, Claire?
So it covers about 16% of our annual energy usage.
We are using the incentives from the state of Massachusetts. So Massachusetts will claim the RECs. So Olin won't be claiming the RECs. And we had a community conversation about, is it still worth doing? Do we want to do it? And we agreed that as part of someone in Massachusetts and broader climate action in general, we wanted to support Massachusetts climate action plan so that the energy or the electricity Olin buys will be greener. So ultimately, we're working with Massachusetts to green the grid so that the electricity we buy long-term is greener.
Thank you.
Yeah.
Please, any questions for Claire or our terrific speakers tonight? Well, this has been fabulous. Many, many thanks to our guests, both participants and our speakers. And thank you, Claire, for letting me put you on the spot there. I think that's a very, very exciting thing happening at Olin right now. So with that, I will say good night and thank you all so much for your interest in sustainability and these alumni programs, and have a wonderful evening.
Thanks, Sally. Thanks, everyone.
Thanks, y'all.
So good to see you, Ellie. Have a great night. Thank you.
To you.
You all set? Do you need